Find the LCM, the least common multiple of 18 and 48. All right, so there's a couple ways about doing this. The first method involves listing the actual multiples of 18 and 48. So for 18, that would be like 18, because 18 times 1 is 18, 36, 18 times 2, 18 times 3, 48, and pretty much etc. That's how that would work out. So let me write a few of those multiples here. And etc. And then for 48, 48 times 1, 48, 48 times 2, 96, 48 times 3, 144, 48 times 4 is 192, and etc. And essentially the way this method works is that you list the multiples and you try to find the smallest common one. And the smallest common one would be 144. These numbers would have an infinite number of multiples between each other that they have in common, but this would be the smallest one between them. Okay, 144. So that's the answer, and that's one way of doing it. However, the disadvantage of this method is that you have to list out all these numbers out, which in the cases where the numbers are really large, maybe like a 3-digit number, yeah, that wouldn't be very helpful or very plausible. It's not gonna work out too well. So let me go ahead and talk about the alternative method here, which is as follows. So what we're going to do is we're going to take our numbers 18 and 48 and factor them into primes. This works out if you just have 2 numbers or 3 numbers for whatever numbers I'm asking to find the LCM for. This will always work out. So we're going to go ahead and factor 18 into its prime factors. So we're going to start asking ourselves, what 2 numbers multiply to give me 18? Well, I can, there's a few there, but 6 and 3. And then 6 itself breaks down as 2 and 3. And that's it. We stop there because we can no longer find any more prime factors. And the prime factorization of 18 would basically be these numbers right here. And you would say 18 equals 2 times 3 times 3, or 2 times 3 squared. Okay. Same thing with 48. I don't know. 8 times 6 is what we can think of. If you want to do 12 times 4, that's fine as well. 2 times 3 is what 6 factors down to. 8 is 4 times 2. And then furthermore, 2 times 2 gives you that. So in our case, 48 would equal 2 to the 4th times 3. And there you go. So those would be your 2 prime factorizations. And here's what we're going to do next. We're going to get the prime factorizations from part 1. And what we're going to do is we're going to grab each prime and write down the largest number of times each of these primes appears. So let's start with 2. Okay. Notice how 2 appears 4 times here, and then just once up here. So 2 to the 4th is what I'm going to write down. And 24, let me redo that. And I'm going to do the same thing for the 3 squared and the 3. 3 appears twice there. So 3 squared is what we're going to write down. And that's how that works out. And essentially for part 3, not much to part 3. To get your LCM, all you do is multiply these 2 values together. So 2 to the 4th times 3 squared, or 16 times 9, 144. Okay. Now, if I had, let's just say for a second, just a 5. Let's say I put a 5 here. And I asked you the same question. Yeah, grab the prime factorizations. The same thing works out for the 2 and the 3 squared, 2 to the 4th and the 3 squared. For the 5, I would just place the 5. So sometimes you'll get a prime factor that only appears in one of the numbers. And that just comes down to the list here. You just write that down, and that's it. Okay? I just wanted to make that point. All right. Thank you for your time.